Section 8.4, Harmonic Motion, Day 2. So we're going to do this Ferris wheel problem. As you ride the Ferris wheel, your distance from the ground varies sinusoidally with time. When the last seat is filled and the Ferris wheel starts, your seat is at the position shown in the figure below. Let t be the number of seconds that have elapsed since the Ferris wheel started. You find that it takes 3 seconds to reach the top, 43 feet above ground, and that the wheel makes a revolution every 8 seconds. The diameter of the wheel is 40 feet. So that's the first thing I'm going to write in, just kind of look at the picture here. So I know that if the diameter is 40 feet, which is this whole thing, then right here, this would be 20, and this would be 20 for the wheel, the radius. And then it also said that we know that the tallest point on our Ferris wheel is 43 feet above ground. If it's 43 feet above ground and the diameter is 40 feet, that means that we are 3 feet above ground right here. Also, another thing is we don't know where my car seat is for the Ferris wheel at t equals 0 because it just tells us that we know after 3 seconds we're at the top, but we don't know what we're at t equals 0 for the time. So some things that we do know, I'm going to write down. We know that the maximum is equal to 43. So the minimum, we said, was equal to 3 because we're 3 feet above ground. Because we're trying to sketch a graph for this. So the next thing that I know is that it makes 1 revolution. So once around is 8 seconds. So that would be the period. We can also figure out the b value that would be from my equation, but we'll do that a little bit later. So from this, if I know my maximum minimum, I can figure out my amplitude of my graph, because remember, it's your maximum minus your minimum divided by 2. So I know that my amplitude in this case is equal to a value of 20, because that would be 40 over 2, which is 20. And then my vertical shift, my d value, is equal to 43 plus 3 over 2. So 46 over 2 would be equal to 23 feet. So that's where my x-axis have moved to. So let's go ahead and start to draw our graph. So our lowest point is 3. Then the next point is our vertical shift, which is 23 feet. And then our next point is our highest point on our graph, which is 43. And I always like to draw in my new x-axis. So for this, we know since the period is 8 seconds, we can figure out our key points. Because remember, your key interval points are moved are in 4 equal parts divided by your period. So 8 divided by 4, which is equal to, in this case, 2. So that's what my key points are going by. Now for this, we don't know where our graph is at time t equals 0. And again, the only thing we do know is that at 3 seconds, that we're at our maximum value, which is up here. So since we're going by 2 points for our key values, then the next 2, which would be 5, we know we could be at our next value, which would be right here. So if that's our maximum, we're going to come down to our vertical shift. At 7, we're going to be here at 3. At 9, we would be back at our vertical shift. And at 11, we would be at the highest point on our graph here. So my graph looks something like this. So again, we know at 3 seconds we're here in a graph. Then we're moving down to here for our next key point. And then we're going to be here for the next key point. And then here for the next one, and then back around. So that's what our graph just did. So for this, it says, we sketch the graph. What is the lowest you go in the Ferris as the Ferris wheel turns? So for B, the lowest you go is 3 feet from the ground, because that's how far up the Ferris wheel is off the ground. It says then for the next part, why is this number greater than 0? And again, it's just because the Ferris wheel is above the ground 3 feet. For C, it says write the particular equation for this curve. So now that I have the curve, I can write a sine or cosine graph for this. This looks like a cosine graph because it goes from a maximum to maximum, which would be the easiest to do. So that's what I'm going to do. So y equals my amplitude, which we said was 20, times the cosine. We need to find out what our b value is. So remember to find your b value. You can do your period is equal to 2 pi over b. So we have 8 equals 2 pi over b. So b would be equal to, in this case, 2 pi over 8, which is pi over 4. And then we have a shift to the right, because instead of starting here, we shifted it to the right to for 3 seconds for x value 3, so x minus 3. And then plus my vertical shift, which is 23. So this would be a cosine equation. If I wanted to figure out a sine equation, I would have to use this point right here, or I could use this point. If I use this point here, then I'm going down first. So it would be, you'd have to have a reflection. So if I did y equals negative 20 times the sine of pi over 4 times x minus 5, because that was my next key point right here, and then plus 23. That would be another equation that I could have. Or I could have done a positive sine graph going up first from here and had a phase shift of 9. So then the next part says we want to predict your height above the ground when t is equal to 6. So that means I'm just plugging t equals 6 into my equation. So for D, and we use x in our equation, so when x equals 6, I'm just going to plug that right in to my calculator, make sure I'm in radian mode. So I'm in radian mode, so we're good. So we have 20. I'm going to use the cosine equation. So 20 times the cosine of pi over 4 times, and we're plugging in 6 for our t or x, so 6 minus 3, because that was my phase shift. Don't forget to close your parentheses, and then plus 23. So when I do that, I get 8.857 feet, so 8.86 feet. So after 6 seconds, we know we're 8.86 feet above ground. So that would be your answer for that one. Okay, so let's skip the other 2 examples, and we're going to go to the one in the back, which is this word problem right here, number 4. For this one, it says the following table shows the average monthly temperature in Cleveland, Ohio, based on the data from 1971 to 2000. Since the average temperatures are not likely to vary much from year to year, the data essentially repeats the same pattern in subsequent years. So a periodic model is appropriate. First, we want to make a scatter plot. So we're going to actually use our calculator to make a scatter plot, and I would use January as 1 since it's 1 normally, so 2, 3, 4, 5, 6, and so on. So that's what I'm going to put into my calculator. So remember to put it in, you go to your stat, enter on edit. We're going to enter list 1 and list 2. So you're going to want to pause the video and enter those values that you have. So notice in list 1 we have the months, and in list 2 are the temperatures. Now if I want to find our make a scatter plot of this, I could, do that on a piece of paper, or we can use our graphing calculator since we just typed it in. So to do that, you need to turn your stat plot on, second y equals. So turn my stat plot on, make sure you're in list 1 and list 2. Then I'm going to go to zoom, 9, because remember zoom 9 makes a nice stat plot for us. So this is what my graph looks like right here. Now, let's think about this a minute. If we want to find an equation for this, let's do it by hand, and then I'm going to show you how to do one in the calculator. So to make an equation by hand, remember, we know how to find the amplitude. It's your maximum minus your minimum divided by 2. We know how to find the vertical shift, doing your maximum plus your minimum divided by 2. And from there, we can also figure out how to do a sign shift. So over here, I need to figure out what is my maximum and what is my minimum value. So in my chart, I found my maximum and minimum value. So I know that the amplitude is equal to my maximum minus my minimum divided by 2, which would be 23.1. Then my vertical shift, or my D value, would be equal to my maximum plus my minimum divided by 2, which would be equal to 48.8. And then for this, let's go ahead and think about the period of my function. So if I'm talking about a year, and we're doing each of the months, then how many months are in a year? 12. So I know the period of the function is equal to 12. So then if I want to find my b value, I do 12 equals 2 pi over b. So then b would be equal to 2 pi over 12, which is equal to pi over 6. And then the next thing I need to do is I need to find my phase shift. So let's go ahead and put in my vertical shift just so you can see it on the graph. So what I'm going to do is in my y equals, I'm going to put 48.8 because that would give me a horizontal line there, and hit graph. So if I'm doing a cosine graph, well, this isn't, this is lowest on my graph, so I know my cosine graph right here is going to start going back up right there. So I could do a cosine graph with a phase shift starting right here, or I can do a sine graph starting from somewhere in here. So I have to figure out where that place is. Well, if I know this is my minimum value, and my minimum value is at, where was my minimum value? So that value was January at 1, 25.7. And this value up here, which is my maximum, was at the value of 71.9. And I want to find essentially the distance in between those two values. So if I want to find the distance in between, you're finding the average. So how do I do that? You take your x values. So you would have, for a sine graph, your x value is going to be 7 plus the 1 divided by 2. So 8 over 2 gives me 4. So I could use a shift for a sine graph of 4. And if you look here, we have 1, 2, 3, 4. So that's right around the 4th point that we had. So that kind of makes sense that we'd have a shift of 4 right there. So if I go back to my equation, I can make a cosine or a sine graph, as we said. So if I did the cosine graph, we would have y equals 23. It would be negative 23.1 times the cosine of my b value times x minus 1, and then plus my vertical shift 48.8. So that would be the cosine graph. If I did the sine graph, I would get y equals 23.1 times the sine of pi over 6 times x minus 4 plus 48.8. I'm going to plug these both into my y equals just to show you what they look like. So what I did is I plugged both the equations that I found into the y equals on my graphing calculator just to show you how well they fit our graph. So if I hit graph, there's my cosine equation that I found. And notice that it looks like it fits pretty well, except for right around here. And then there's the second equation with the sine graph, which essentially is the same thing. I just made it a little bit thicker so that you could see it's the same line. So either equations of the two equations would be good. So those are our two equations, and it says, now we want to use the sine regression feature on our calculator to find another sinusoidal model for the data. So for this, there is a sine regression feature. So if I go to, I'm going to quit out of here and go to stat. If you go to calculate, And if you go all the way down to right here, it says sine regression. So if I hit enter, and then I hit enter, it's going to come up with the equation that I just did. And notice that when they do this equation for your calculator, they're not factoring out that b value, they're leaving it in. So our phase shift looks a little bit different. So I'm going to write this equation down so that we have it over here. So I wrote the equation down, and then if you'll notice this equation that's below it in blue, what I did was factor out that b value so that we can write the equation as we normally do. And notice when I factored out the b value, if I do 2.05 divided by 0.5017, I get 4.086, which is very close to our phase shift right here. I want to take that b value. Remember that when we want to find the period of our equation, it's 2 pi divided by your b value. So if I do 2 pi divided by 0.5017 in my calculator, I end up with this being equal to a period of 12.5237. So I'm sure I have a little bit of rounding error with that. So this tells me that our model probably fits the data a little bit better than the calculator one, because you notice that this would say we have a little bit over a year, and we know that we can only use 1 year for each of the temperatures that we have. So that's one way that they differ. They differ between the period and also the fact that the calculator one had the non-factored form for our sine and cosine. So then E says use the calculator model to predict the times of year which the average temperature is 45 degrees. So if I want to predict the time of year when it's 45 degrees, I'm plugging that into my y equals. And I'm going to look at the intersection for the two. So in my y equals, I'm going to leave my cosine graph and just clear this one out. So I'm going to do 45. And you want to make sure you can use your equation, or it actually says use the calculator model, so I should plug that one in. So to plug that one in, let's do, if I go to stat, calculate, and it's all the way down at C. So sine regression, vars, y vars, I'm going to put this into y1. So now my equation should be in y1, which it is. So if I go to second, if I just go to graph, I should have my two equations. And so if I want to find the time where it is 45 degrees, I would do the intersection. So second trace, intersection. And if I go over, here and hit enter, enter, enter 3 times, I get an x value of 3 point something. So if it's 3 point something, then think about your months. January, February, March would be the third month, and it's actually in late March because it's 3.76. So I would say late March, and then also second trace, intersection. Let's go to the other side. And find the intersection. And then, so this one's 10. So for 10, we know that's October. So late March and also late October. So late March and October would give me the temperature, average temperature being around 45 degrees Fahrenheit. So you don't have to do any of the other problems. We're going to go ahead and work on those in class, but make sure that you bring these with you to